You can forget about panning for gold in some dusty river. The new gold rush, the real one, is happening miles below the ocean's surface in complete and total darkness. And the treasure? It's not some shiny metal, it's the genetic code of life itself. Now, to really get what's going on here, you have to understand something crucial. The deep sea, it isn't just another part of our world. It's basically an alien planet, hidden right here on Earth, and it operates by a completely different set of rules. I mean, we're talking about an environment of unimaginable extremes. The pressure is so intense it can crush steel. The darkness is absolute, it is eternal. And the life that actually manages to survive down there, well, it's unlike anything you have ever seen, I promise you. Which, brings up a couple of massive questions. First, how on earth do we even explore a place like this? And second, what in the world are we finding that's so incredibly valuable? So let's start with just the sheer scale of it all. The deep ocean is, and I don't think this is an exaggeration, truly Earth's final frontier. Okay, here's a number that's probably going to blow your mind. We have more detailed, high-resolution maps of the surface of Mars and the Moon than we do of our own planet's seafloor. Less than 0.1% of it has been looked at in any real detail. Just think about that. And check this out. Over half, more than 50% of the entire seabed is over 3,000 meters down. That means the vast majority of our planet's livable space, its volume, isn't on land, it's not in the sunny parts of the ocean, it's in this deep, dark, mysterious world. And it is not empty, not at all. Life down there clusters around these incredible oases, things like hydrothermal vents that are spewing superheated chemicals, or cold seeps leaking methane from the earth, and even the skeletons of giant whales that have fallen to the seafloor. These are entire ecosystems powered by chemistry, not sunlight. So how do we reach these bizarre places? Well, that takes some seriously incredible technology. These are the tools of discovery that make any of this even possible. You can kind of see the whole story unfold right here on this timeline. It really kicked off with human pioneers in subs like Alvin, which, by the way, completely rewrote biology textbooks in '79 when it found those vent communities. Then came the robots in the '80s. And since the year 2000, it's just been a technological explosion, and the pace of discovery has gone vertical. So today, we've got a whole fleet of robotic explorers. You've got your HOVs, which actually put human eyeballs right on the seafloor. Then there are ROVs, which are kind of like our remote hands tethered to a ship. And finally, you have AUVs. They're the scouts, untethered robots just running their pre-programmed missions all on their own. And all of this incredible exploration has triggered something new. It's a rush, but it's not for gold or for oil. It's for genetic code. The treasure everyone is after is something called marine genetic resources, or MGRs. To put it simply, it's the DNA itself. It's the unique biological blueprints of deep-sea life. And those blueprints hold just immense potential value. And this chart illustrates that trend perfectly. You see it right there. Better technology to get to the deep sea leads directly to discovering more new species. More tech means more access, and more access means finding more of this incredibly valuable genetic code. It's a direct line. So why is this DNA so valuable? Well, think about it. To survive in that crushing pressure and total darkness, these organisms had to develop unique biochemistry, stuff found literally nowhere else on Earth. And that's why the success rate for finding new drugs for marine life is 2 to 4 times higher than from any source you can find on land. This incredible potential, well, it leads directly to patents. So let's take a look at who is actually staking a claim to the genetic code of the deep sea. In other words, who's locking down the exclusive rights to use these biological blueprints to make commercial products? And the players in this so-called gold rush, well, they're a pretty concentrated group. You got a handful of major transnational corporations, headquartered in just a few wealthy countries, and they are absolutely dominating the field. We're talking giants like Germany's BASF and America's DuPont, right at the front of the line. So just how concentrated is it? Well, check out this number. A staggering 58% of all patents that involve marine genetic sequences are held by just 100 entities. That is a very small club of corporations and universities. But here's the real twist in this whole story. These companies, they aren't all sending their own high-tech submarines down to the abyss. No, Many of them are simply mining vast public gene databases filled with genetic information that was collected by taxpayer-funded scientific expeditions. They're prospecting for gold in data that was meant for everyone. All of which brings us to the final and I think the most critical question of all. If this frontier belongs to everyone on Earth, then who gets to profit from it? Who owns the abyss? See, most of this prospecting is happening in a legal gray zone. It's known as areas beyond national jurisdiction. We're talking about the high seas, the ultimate global commons, and it makes up nearly 2/3 of our entire ocean. It's huge. And this chart right here, this really highlights the core dilemma we're facing. Species that are found only in these ungoverned high seas are 2.5 times more likely to be deep-sea creatures. So what does that mean? It means the most unique, the most bizarre, and potentially the most valuable life on the planet, it exists in the least protected places. And remember those biological oases we talked about? Well, over half of all known hydrothermal vents, these incredible hotspots of unique evolution and valuable genetic material, they're located out in what is essentially the Wild West of the high seas. So here's where we're left. We finally have the technology to reach the last unknown frontier on our own planet. It's incredible. But as this genetic gold rush picks up speed, the real question isn't just what we're going to find down there, it's whether we can figure out who owns it and who benefits before private interests manage to stake a claim on what might just be the common heritage of all humanity.